March 1945. The Rhine River, swollen and cold, flowed like liquid steel under a gray, overcast sky. On the western bank, German soldiers crouched behind sandbags and shattered trees, binoculars pressed to their eyes. Smoke drifted from villages already reduced to rubble. Shells shrieked overhead, striking water and earth alike, sending plumes of mud and debris into the air. Through the mist, they saw it. American engineers wading into the river, heavy pontoons in tow, assembling sections of a portable bridge while under direct fire. Rifle bursts cracked against the current. Artillery rounds tore the banks, yet the engineers pressed on, hammers ringing against steel, cables straining, every plank and beam tested by the river's icy surge. The Germans exchanged incredulous glances. "They're building under fire?" whispered one. Another shook his head, disbelief etched into his face. Across dozens of meters, the Americans advanced steadily, bridging the gap that should have been impossible to cross, defying logic. Courage stacked against danger like bricks. By midday, a faint path had formed across the river. German officers realized with growing horror that what they assumed would stall the Allies for weeks might be overcome in hours. Every heartbeat on the bank measured anticipation, dread, and disbelief. The river, the engineers, and the guns combined into a spectacle of audacity that would be remembered by every man watching. A moment when technology, courage, and sheer determination collided on the battlefield. The river would not yield easily, but soon it would bear the weight of a crossing that the Germans could hardly believe possible. By early 1945, the war in Western Europe had reached a decisive phase. The Allied armies, following the breakout from Normandy and the liberation of France, pressed relentlessly into Germany. Every river, ridge, and town represented both a tactical challenge and an opportunity. Among these natural obstacles, the Rhine River stood as a formidable barrier, wide, deep, and swollen by early spring rains. Its banks were steep, often marshy, and easily defensible. For the German High Command, the Rhine was more than water. It was a line of honor, a natural shield against the advancing Allies. German soldiers along the Rhine had been preparing for months. Fortifications lined the river. Anti-tank obstacles, trenches, and machine gun nests overlooked potential crossing points. Mines and booby traps filled the approaches, while artillery batteries targeted likely landing zones. Commanders believed that any Allied attempt would be slow, predictable, and costly, a ritual of attrition that could buy time to reinforce the Western heartland. For the men stationed on the banks, the Rhine was both a defensive promise and a psychological anchor. For the Americans, the challenge was immediate. Crossing a major river under enemy fire had long been one of the most dangerous operations in warfare. Traditional pontoon bridges were slow, vulnerable, and labor-intensive. Yet the pace of the Allied advance demanded speed. Engineers trained to erect portable bridges, including the modular Bailey bridges and pontoons, were essential to maintain momentum. Every delay could allow the Germans to reorganize, to strike with artillery, or to counterattack. The task fell to specialized units, U.S. Army combat engineers, supported by infantry and armored divisions. These men were expected to carry heavy components, assemble complex structures, and do so under the threat of gunfire and shelling. Speed, precision, and courage were non-negotiable. Their success would determine whether an entire sector could be penetrated, or whether the Rhine would remain a formidable barrier for weeks. The Germans, observing from fortified positions, were confident. Their reconnaissance had identified assembly points and likely approaches. Officers expected the Allies to suffer high casualties before successfully bridging the river, and yet intelligence reports noted unusual American efficiency, suggesting new tactics, improved portable bridges, and unprecedented coordination between engineers and infantry. To the Germans, the reports were curious, almost unbelievable. Could men truly construct a bridge under fire, and allow tanks, artillery, and infantry to follow almost immediately? In the early morning light, mist rose from the Rhine, obscuring the river's width and the treacherous currents. German observers focused binoculars on the western bank, calculating trajectories, shell ranges, and expected landing zones. Every movement was noted, every small detail scrutinized. Yet what they could not anticipate was the combination of American ingenuity, engineering skill, and sheer determination that would soon confront them. The stage was set. On one side, a river designed to halt armies, defended by soldiers steeped in expectation and discipline. On the other, engineers and soldiers prepared to challenge every assumption, assembling bridges, moving heavy equipment, and forcing passage where it seemed impossible. The collision of these forces would define the Rhine crossings and leave German troops in disbelief. The river awaited, indifferent to strategy, but ready to witness audacity in action. Crossing the Rhine was more than a matter of courage. It was an engineering problem of immense complexity. The river's width varied from 200 to over 400 meters in key sectors, and its strong currents threatened any floating structure. Banks were often steep or muddy, making the placement of pontoons or supports difficult. High water levels in early spring exacerbated these challenges, as swollen tributaries fed into the river, creating unpredictable eddies and whirlpools. Every bridge had to be strong enough to support infantry, vehicles, and even tanks, yet portable enough to be assembled rapidly under fire. The U.S. Army relied heavily on Bailey bridges, modular, prefabricated steel trusses that could be transported in sections, assembled on site and launched over gaps with minimal heavy machinery. These bridges were revolutionary in their flexibility. Engineers could build a single-span bridge in hours, adjust length to fit the river, and reinforce it for armor crossings. Floating pontoons were also used, particularly in sections where current or depth made fixed supports impractical. Pontoons required precise positioning, coordination of flotation units, and careful anchoring, all while under enemy observation and artillery fire. Combat engineers trained relentlessly for such operations. Drills emphasized speed, teamwork, and improvisation. Each soldier knew the sequence: lay the pontoons, connect decking, secure trusses, and open the path for infantry. Under ideal conditions, a small unit could establish a crossing in a matter of hours. Under fire, the difficulty multiplied exponentially. Rifle and machine gun fire could strike any exposed worker. Artillery rounds threatened the entire assembly. Even a single mistake could collapse the bridge, endanger dozens of men, and halt the advance. German reconnaissance units were acutely aware of the stakes. Observers used binoculars and periscopes to identify potential crossing points. Aerial reconnaissance provided additional intelligence, noting the movement of engineer units and identifying weak spots in the riverbank. German artillery officers placed pre-registered fire coordinates along likely approaches, expecting to disrupt bridge construction and inflict maximum casualties. Officers believed that the Americans would follow predictable engineering procedures, assembling pontoons in order, building gradually from one bank, and exposing themselves in concentrated groups. Yet intelligence reports hinted at something unusual. Reconnaissance noted that American engineers were working in smaller, more dispersed teams, often starting multiple assembly points simultaneously. Speed and adaptability allowed them to react to enemy fire almost instantly. The Germans were intrigued but skeptical. Could small groups truly assemble bridges capable of supporting tanks under such conditions? Was this standard procedure, or a new tactic that defied expectations? Meanwhile, American planners studied the terrain meticulously. Engineers measured current speeds, water depths, and bank angles. They calculated load-bearing limits and stress points for Bailey bridges, accounting for both static and dynamic weight. Field tests were conducted in safer sectors to refine assembly techniques. Infantry and armor units trained to cross quickly once the bridge was operational, minimizing exposure to German fire. Coordination between artillery, engineers, and infantry was critical. Suppressive fire could neutralize enemy positions while bridges were being completed. By mid-March 1945, all preparations were in place. The Rhine awaited, formidable and indifferent. German troops manned the high ground, confident in their fortifications, artillery, and observation. American engineers and soldiers, however, brought innovation, courage, and untested techniques to the riverbank. Both sides were poised for a collision that would test human ingenuity, discipline, and endurance under fire. The stage was set for the audacious crossings that would leave German soldiers in disbelief and demonstrate the transformative power of engineering. In modern warfare, for German soldiers observing the riverbank, the sight was almost surreal. Weeks of planning, reconnaissance, and artillery preparation had created a sense of control over the battlefield. Yet here were American engineers, wading into freezing waters, assembling heavy steel bridges piece by piece, while shells and bullets tore the air around them. Fear, disbelief, and grudging respect mingled on the faces of the German troops. Soldiers whispered among themselves, "How can they work like this?" One officer noted in his log that men seemed frozen in both admiration and dread, unable to believe their eyes. The engineers moved with mechanical precision, yet each action carried immense risk. Every plank, every cable, and every pontoon could mean life or death. Yet they advanced steadily, guided by training, coordination, and sheer determination. American infantry backing the engineers faced similar human challenges. They had to provide suppressive fire, carry heavy loads, and maintain situational awareness while crossing open terrain under enemy observation. Exhaustion, adrenaline, and fear intertwined. Soldiers described the roar of artillery as a constant companion, deafening, disorienting, yet strangely rhythmic, marking each stage of construction and advance. The psychological strain tested every man's nerves. A single lapse could result in catastrophe. The collapse of a bridge, a fallen comrade, or a stalled assault. The human angle extended to leadership. Officers, non-commissioned officers, and unit commanders bore the responsibility of both morale and precision. Decisions had to be instantaneous. When to advance, when to suppress enemy fire, when to adjust bridge positions. Mistakes were not measured in lost time, but in lives. The courage displayed was not flamboyant heroism, it was methodical, calculated, and unwavering under the weight of mortal danger. Through this human lens, the Rhine crossing was less a technical feat and more a test of discipline, courage, and endurance. The soldier's ability to function under chaos, to maintain cohesion amid relentless fire, and to perform extraordinary tasks despite mortal risk defined the outcome even before the first vehicle rolled onto the bridge. The technological ingenuity of portable bridges reshaped the battlefield. Bailey bridges, with their modular steel trusses, represented a revolution in military engineering. They could be transported in trucks, assembled rapidly on site, and reinforced to support tanks and artillery. Unlike traditional pontoon bridges, which were slower and more vulnerable, Bailey bridges combined speed, flexibility, and load-bearing strength, a critical advantage in river crossing operations. Engineers faced enormous technical challenges. Currents, river depth, and soft banks threatened stability. Heavy components had to be carried into position while under fire. Every joint, cable, and pontoon had to be tested for load-bearing capacity, sometimes while bullets and shrapnel struck nearby. Even the simplest mistake, a misaligned pontoon or a loose truss, could collapse the entire bridge. Field ingenuity was essential. Sandbags reinforced weak points, small boats stabilized sections, and temporary anchors resisted the pull of the current. Pontoons complemented the Bailey bridges in shallow or rapid sections. Floating platforms required precise coordination, timing, and anchoring. Engineers had to account for shifting currents, variable weight distribution, and artillery strikes. Each section was a balance of physics and practical improvisation, demanding constant adjustment and careful teamwork. German soldiers watched in disbelief. Their intelligence had anticipated conventional crossings, slow and predictable. The Americans' modular approach allowed simultaneous assembly at multiple points. Engineers could replace damaged sections instantly, adapt to unexpected conditions, and maintain continuous progress. The speed and flexibility defied German expectations. What was thought impossible, constructing a bridge under direct fire capable of supporting armor, became reality. Technology, in this case, was inseparable from human skill. The design of the bridges, the precision of assembly, and the synchronization with infantry and artillery all depended on trained, disciplined soldiers. The Rhine crossings demonstrated that engineering prowess could multiply human effectiveness, transforming a natural barrier into a conduit for rapid, audacious assault. The banks of the Rhine had become a stage for both human courage and technological innovation. Soldiers on both sides confronted not just bullets and shells, but the limits of endurance, ingenuity, and disbelief. Leadership during the Rhine crossings was both strategic and immediate. On the American side, commanders at every level were acutely aware that success depended on precise coordination. Engineers could not work in isolation. Infantry had to suppress enemy positions, armored units had to be ready to advance, and artillery needed to neutralize German guns. Decisions had to be made under intense pressure, with incomplete information, and often while under fire. Brigadier generals and battalion commanders monitored progress from observation posts, using maps, radios, and visual signals to direct multiple teams simultaneously. The timing of each bridge section, the sequencing of infantry support, and the rotation of engineers were all critical. Delays could result in exposed troops, failed construction, and lost momentum. Leadership demanded both technical knowledge and an intuitive understanding of human endurance. On the German side, officers faced a crisis of disbelief. Defensive plans assumed the river's natural obstacles and prepared fortifications would buy time. Yet American initiative and engineering skill disrupted these assumptions. Leaders attempted to coordinate artillery fire, reposition machine guns, and issue orders to troops. But communication breakdowns and rapid enemy progress undermined their control. The clash highlighted the decisive role of leadership under conditions where courage, innovation, and audacity could overcome numerical or positional advantages. German soldiers and officers were stunned by the audacity of the crossing. From their fortified positions on the riverbank, they observed engineers moving deliberately yet fearlessly under fire. Reconnaissance reports had predicted slow, methodical construction, yet the Americans advanced with speed and confidence that seemed impossible. Soldiers described their disbelief in diaries and after-action reports. "They walk into fire as if it were a parade," wrote one artillery officer. "How can men remain so calm while building a bridge in plain sight?" This perspective captures the psychological impact, not just the threat of physical danger, but the erosion of expectation. Defenders accustomed to slowing attackers with natural obstacles and firepower faced men who refused to be delayed by either. The Rhine crossing challenged German tactical assumptions. Standard firing zones, pre-registered artillery targets, and fortified positions were suddenly less effective. The combination of dispersed assembly, rapid adaptation, and relentless advance left German troops questioning both their training and the limits of conventional defense. The moral dimension of the Rhine crossings was stark. Engineers and infantry exposed themselves to mortal danger, building bridges under direct observation of enemy fire. Each act of assembly risked dozens of lives, yet success was critical for the overall offensive. Commanders accepted these risks as necessary, balancing the value of rapid advance against the potential cost in human life. From the German perspective, witnessing the Americans' exposed engineering work provoked a mix of fear and respect. Men were killed or wounded in the process, yet the operation's audacity inspired unease. If such determination could overcome any obstacle, what hope remained for static defenses? Moral resolve in this context was tested on both sides. Courage became an operational tool, while fear and disbelief undermined defensive cohesion. The crossings also highlighted the broader ethical realities of industrialized warfare. Success depended not only on bravery and ingenuity, but also on the willingness to place lives in extreme jeopardy for strategic gain. In this sense, the Rhine crossings were both a triumph of human skill and a stark reminder of war's inherent cost. In these perspectives, leadership, enemy reaction, and moral choice, the Rhine crossings reveal the complexity of warfare. Courage, ingenuity, and human psychology intersected with technology and strategy to create moments of disbelief and audacity. March 23, 1945. Dawn broke over the Rhine with an eerie stillness, the gray mist curling off the water's surface. German positions lined the western bank, their machine guns, mortars, and artillery trained on the river. Observers scanned for movement, confident that the natural barrier and their preparations would stall any attempt at crossing. On the eastern bank, American engineers and infantry moved into position. Soldiers carried steel trusses, pontoons, and tools through knee-deep water. Each step sent ripples across the river, betraying their presence to German eyes. From the bank, rifle and machine gun fire cracked like the staccato of a mechanical drum. Explosions from artillery shells shook the riverbanks, tossing mud and debris into the air. the engineers did not falter. Teams worked in coordinated rhythm. Pontoons floated into position, decking was secured, trusses raised, and cables tightened. Small boats ferried additional components across the current, while infantry provided suppressive fire, keeping German heads down. Every movement was precise, rehearsed, and relentless. The first sections of bridge took shape under conditions that would have broken lesser men. German artillery attempted to disrupt the assembly. Pre-registered shells targeted likely crossing points, creating explosions that sent water and timber into the air. Mortars rained down, and machine gun crews opened fire from fortified positions. Soldiers on the eastern bank ducked, shouted, and pressed forward. Yet each section completed increased the pressure on the defenders. For the Germans, the speed and audacity of the operation defied their calculations. Their firing zones, carefully planned, were insufficient to stop small, dispersed teams working in parallel. Infantry units began to cross the partially completed bridge, testing its integrity. Tanks and armored vehicles followed, rolling across the modular steel in a display of precise engineering and nerve. German officers recorded the moment with disbelief. Armored vehicles moving across a bridge being constructed under their direct observation was unprecedented. Morale faltered as the reality set in. The Allies were advancing despite the natural and prepared obstacles meant to halt them. The river became a tableau of human courage under fire. Engineers worked with hammers ringing against steel. Soldiers carried ammunition and supplies, and infantry kept the enemy suppressed. Every step forward was a battle of physics, nerves, and determination. Casualties occurred, yet the operation continued, each loss absorbed into the rhythm of progress. By midday, a continuous span had been established. Vehicles and troops streamed across, consolidating a foothold on the western bank. German soldiers retreated from exposed positions, artillery shifted to secondary targets, and officers attempted to reorganize defenses. Yet the initial crossing had shattered the first line of confidence. The Rhine, long considered an insurmountable barrier, had been overcome through a combination of planning, courage, and innovation. The first breakthrough was complete, but the battle was far from over. German forces scrambled to respond. Artillery and machine guns repositioned, and engineers prepared to extend the bridge further upstream. The psychological impact was profound. Defenders who had anticipated weeks of delay were confronted with rapid, unstoppable momentum. The collision of audacity, technology, and discipline had reached its first apex. American forces had proven that portable bridges, when combined with precise coordination and fearless execution, could achieve what the enemy deemed impossible. The stage was set for the final phases of the Rhine crossings, where German resistance would continue to falter under relentless pressure. By late March 1945, the initial footholds on the western bank had been secured, but the battle was far from over. German artillery continued to hammer the riverbank, shells plowing through mud, steel, and timber. Machine guns and mortars targeted the bridging points, yet American engineers and infantry pressed forward, extending the Bailey and pontoon bridges further upstream. Every new section faced deadly scrutiny, every beam a potential death trap. The Germans scrambled to respond. Officers shouted orders, repositioning artillery to cover weak points, while small units attempted counterattacks on exposed engineers. Yet the speed and coordination of the Americans rendered these efforts largely ineffective. Engineers repaired damaged sections under fire, infantry suppressed gun nests, and armored units rolled across completed spans, pushing the line forward. The psychological effect was immediate. Disbelief and demoralization spread among German soldiers, many of whom could not comprehend how men could work so methodically under constant threat. At midday, a critical moment arrived. American engineers launched a new pontoon section across the fastest, deepest stretch of the river, a point previously considered impassable under fire. German artillery had been concentrated here for days, yet the engineers moved in dispersed teams, erecting the structure with rapid precision. Bullets struck, shells exploded nearby, yet each section rose from the water, buoyed by both ingenuity and sheer determination. By the afternoon, tanks and infantry were advancing across this section, opening a route that would render the river a passage, not a barrier. The German command realized the inevitability of collapse. Defensive positions along the western bank were being bypassed or neutralized. Orders became fragmented. Some units attempted local resistance while others withdrew in disarray. The Rhine, which had long been seen as the ultimate obstacle, had been breached decisively in hours. Officers recorded the moment with a mixture of horror and awe. The combination of engineering skill, courage, and tactical planning had overwhelmed centuries of defensive doctrine. American leadership coordinated the crossing with meticulous timing. Artillery fire was shifted to suppress remaining German positions, infantry moved in waves to consolidate the bridgehead, and engineers prepared to repair or extend bridges as necessary. Every action was synchronized, a seamless blend of human skill and technology. The river no longer dictated terms. The Americans controlled it. By nightfall, multiple bridging points were operational. Infantry and armor streamed across, cutting off retreating German forces and establishing firm control over the western bank. German artillery positions were overrun or silenced, and communication breakdowns rendered counterattacks largely ineffective. The Rhine crossings, once a formidable obstacle, had become a symbol of American audacity and engineering mastery. The human cost was high, yet the momentum was unstoppable. Engineers, infantry, and armor had achieved what German commanders had considered impossible. The crossing marked a turning point not only in the sector, but in the entire Western campaign. The path into the heart of Germany was open, and the Allies could maintain their relentless advance. The psychological and strategic impact was profound. German soldiers who had witnessed the construction under fire were demoralized. Confidence in fortifications, natural barriers, and pre-registered artillery had been shattered. For American forces, the operation validated combined arms doctrine, engineering innovation, and the principle that speed and audacity could overcome even the most formidable defenses. By the end of the day, the Rhine was no longer a boundary but a conquered obstacle. Engineers rested only briefly, infantry secured positions, and commanders began planning the next phase of the advance. The audacity of building portable bridges under fire had not only crossed a river, it had crossed the threshold of belief, leaving the German defenders to reckon with a new reality. The Allies could overcome obstacles once thought insurmountable. The Rhine crossings left the western bank in chaos. German defensive positions once formidable were shattered. Machine gun nests lay in rubble, artillery emplacements destroyed or captured, and trenches flooded with mud and debris. Officers struggled to maintain command as units retreated in disarray, their cohesion eroded by disbelief and exhaustion. The psychological impact was immediate. Men who had expected to delay the Allies for days, perhaps weeks, found themselves overrun in hours. German soldiers faced the grim reality of failure. Diaries and after-action reports describe a mix of anger, disbelief, and fear. Some attempted to regroup, manning secondary positions or launching small counterattacks, but coordination was nearly impossible. Communication lines were disrupted, officers were killed or incapacitated, and morale plummeted. Soldiers who had been confident in the natural barrier of the Rhine now confronted the stark truth. The Allies had overcome the river with engineering skill, courage, and relentless momentum. For the Americans, the victory came at a heavy cost. Engineers and infantry endured casualties from artillery, machine gun fire, and mines. Yet the success of the operation validated months of training, planning, and innovation. Portable bridges had performed under extreme conditions, allowing armored units to advance rapidly and secure the riverbank. Commanders noted the operation as a textbook example of combined arms, coordination, and the integration of technology and human skill under combat conditions. Civilians along the Rhine were caught in the turmoil. Villages near crossing points had been shelled, partially destroyed, and evacuated. Families hid in cellars or fled under the cover of smoke and debris. The sudden movement of Allied forces through these areas brought both relief from German occupation and exposure to the dangers of active combat. Eyewitness accounts describe the terror of artillery barrages, the sight of bridges rising under fire, and the sudden arrival of foreign troops. A mix of fear, awe, and the uncertainty of survival. The crossings also highlighted the limitations of German planning. Pre-registered artillery fire, defensive fortifications, and riverbank obstacles had been insufficient. Engineers working in dispersed teams, Building multiple bridges simultaneously nullified the advantage of fixed defenses. The operational tempo of the Americans ensured that momentum was maintained, preventing the Germans from regrouping effectively. What had been expected to be a prolonged standoff became a rapid collapse. Strategically, the successful crossings forced a reallocation of German forces. Units previously stationed to guard the Rhine had to retreat or redeploy, leaving other sectors exposed. Allied forces could push further into Germany with speed, bypassing obstacles that had once been considered nearly impregnable. The river, a symbol of German defensive strength, had been conquered, signaling a shift in the psychological and operational landscape of the Western Front. In the immediate aftermath, the Rhine crossings demonstrated a critical truth. The combination of audacious leadership, disciplined soldiers, and technological innovation could overwhelm even the most prepared defenses. The bridgeheads secured by American forces became launch points for further advances, leaving German troops demoralized and the path into the heart of Germany increasingly open. The Rhine crossings were more than a tactical victory. They were a strategic shockwave that reverberated across the German command. For the Wehrmacht, the river had been a final natural barrier before the industrial heartland of the Reich. Its breach meant that the Allies could now push into Western Germany with unprecedented speed, rendering months of defensive planning obsolete. Fortified positions, pre-registered artillery zones, and natural obstacles no longer guaranteed delay. German high command was forced into a reactive stance, reallocating troops to plug gaps that had already been exploited. Morale among German soldiers deteriorated rapidly. Units that had prided themselves on holding the Rhine faced the stark reality of being outmatched not by overwhelming numbers, but by audacity, coordination, and innovation. Diaries and intercepted communications described disbelief turning into resignation. Some soldiers attempted local counterattacks, but they were piecemeal and ineffective. The psychological toll of watching engineers construct bridges under constant fire, while armored columns rolled across them, eroded the defenders' sense of control. For American forces, the crossings validated months of preparation and training. Combat engineers were hailed as pivotal to the success, their technical skill directly influencing operational outcomes. Commanders emphasized the importance of combined arms, artillery, infantry, armor, and engineering units working in seamless coordination. The operation became a model for future river crossing operations, demonstrating that with meticulous planning, audacity, and technological advantage, even heavily defended obstacles could be overcome efficiently. The broader Allied advance was accelerated. With the Rhine breached, armored divisions penetrated deeper into Western Germany, linking with airborne and infantry units to exploit gaps in German lines. Cities and towns that had expected weeks of defensive resistance now faced rapid occupation. The speed of movement left the Germans disoriented and unprepared for successive offensives. Logistical lines for the Allies also improved, as bridges enabled faster movement of supplies, artillery, and reinforcements, maintaining operational momentum. Civilians, meanwhile, experienced the immediate consequences of these operations. Towns along the Western Bank were subjected to artillery bombardments, shelling, and the sudden influx of advancing troops. Refugees fled along exposed roads, navigating destroyed infrastructure and the chaos of active combat. While the Allied advance promised liberation from German occupation, it also imposed severe hardships on local populations, a reminder of the human cost of rapid, industrialized warfare. The Rhine crossings left lasting impressions on both sides. German forces came to recognize the limits of static defenses and the psychological weight of witnessing enemy ingenuity under fire. American forces reinforced the lessons of speed, audacity, and the integration of engineering capabilities with combat operations. In operational reports, commanders noted that the crossings exemplified how technology, planning, and human courage could combine to neutralize natural and man-made obstacles that had once seemed insurmountable. Ultimately, the Rhine had ceased to be a barrier. Its breach signified a turning point in the Western campaign. The Allies were now inside Germany's core, and the Wehrmacht's ability to defend the heartland was severely compromised. The audacity of constructing portable bridges under fire had not only enabled tactical success, but had reshaped the strategic landscape, leaving a legacy of innovation, courage, and decisive action that would define the closing months of the war in Europe. The Rhine crossings were more than a military operation. They were a testament to the intersection of human courage and technological innovation. For decades, rivers had shaped battles, offering natural defense and slowing armies. Yet on that March day in 1945, engineers and soldiers demonstrated that ingenuity, coordination, and determination could redefine what was possible on the battlefield. For the German defenders, the crossings shattered long-held assumptions. Discipline, fortification, and natural obstacles, once considered reliable, were rendered vulnerable to audacity and precision. Fear and disbelief replaced confidence as soldiers witnessed men working methodically under fire, assembling bridges capable of bearing tanks and artillery. The psychological impact was profound. Even a well-prepared defense could be undone not by sheer numbers, but by the calculated blend of skill, courage, and innovation. For the Allies, the crossings exemplified the evolution of modern warfare. Combat engineers became central to operational success, their technical skill directly shaping outcomes. The combination of modular bridge technology, careful planning, and synchronized action turned a natural barrier into a conduit for rapid advance. Courage, in this context, was measured not in dramatic heroics, but in disciplined execution under constant threat. The crossings also underscore the broader human cost of industrialized war. Lives were risked to overcome obstacles. Civilians experienced the upheaval of combat, and soldiers endured exhaustion and terror. Yet these sacrifices were instrumental in shaping the course of history. The Rhine, once a symbol of impassable defense, became a monument to audacity and adaptability. In the quiet after the battle, the river flowed on, indifferent to the struggle it had witnessed. But the echoes of courage, innovation, and relentless determination remained. The Rhine crossings serve as a reminder that in warfare and in life, obstacles, no matter how imposing, can be overcome through preparation, ingenuity, and unyielding resolve. They teach that human endurance, coupled with technical mastery, can challenge assumptions, alter expectations, and redefine the limits of possibility.